All right, so we're on the second page of the 11.1 notes, and I want to talk about the metric system. So the metric system really is an ideal system of measurement. I know sometimes it doesn't feel like it's ideal to us because we're not as used to using it, because when most of us grew up, we may have learned about the metric system in school, but a lot of the measurement that we tend to use in day-to-day life in the United States is is the English system. So by English, I mean inches, feet, that kind of thing, yards, acres, miles. So the metric system is so much more ideal than the English system for a couple of reasons. One, it's portable. So if you think about the measurement of a foot, for example, so the foot came from an actual king's foot, a king that is no longer even alive. So yes, we have a lot of rulers and feet that have been measured, in our world today. So it's not like we're going to lose it or anything, but it's definitely, an arbitrary measurement. In contrast, the metric system, when we think about like a meter, it's an actual measurement of wavelengths of orange-red light. So, and no, we're not, the average person is not going to go and be able to measure any wavelengths of orange-red light, but it is, it's a measurement of something that exists on our planet, beyond just one single person. So, the other nice thing about the metric system is that it's very easy to convert. So you might have noticed in previous examples, like I'll just scroll up here because I have the last example filled in, like when we did the pounds to tons example, we had to set up a proportion for that. And you can certainly do proportions for metric systems, but it is so much easier. Everything is basically a factor or a multiple of 10. And so that allows us to really just move decimals instead of creating these big, equations to solve. And then the other thing that's nice about the metric system is all the units are related to each other. So we've got this nice chart here. And basically, I'm just going to draw a line right in the middle. So right here, this is sort of like our base measurement. We can think of that as like a meter. Okay. And then anything above it, you'll notice these are negative exponents, so these are all smaller measurements. And anything below it, these are larger. So, for example, if we put the word deci in front of meter, decimeter, it is 1/10 of a meter. Or if we put centimeter, it's 1/100th of a meter. Or millimeter is 1/1000th. If you go bigger, like decameter, you'll see there's a 10 here. That means a decameter is 10 times bigger than a meter. Or a hectometer is 100 times bigger than a meter. So they're all related to each other. So let's go ahead and we're going to just jump down here. And we're going to do example 3. Now this metric converter for the metric system is super handy, and I'm going to talk about that in example 4. But let's go through example 3 first. So example 3 asks about miles and kilometers. So I'm just going to circle the conversion right up here. So we know that 1 mile is equal to 5/3 of a kilometer. So going to come down here. So it says if a person walks 3 miles an hour, approximately how many kilometers per hour does the person walk? So I'm going to do this in a different way than I did the previous examples because I want to show you how to use it's called dimensional analysis. And a dimensional analysis is nice because really what it involves is just multiplying fractions. So you're going to have fractions like a over b times b over c times d over a, for example. And instead of putting a fraction equal to each other like in a proportion, we're multiplying the fractions. And the goal in dimensional analysis basically is to cancel out terms. So you might remember with fractions, if you have a fraction like 1/2 times 2/5, for example, if the 2's on the diagonal can be canceled out, okay, because they divide into each other, they're divisible by the same number. And we're going to use the same idea here with dimensional analysis. So what we do is we start by just writing down what was given to us in the problem. So if this person walks 3 miles per hour, we're going to write it as a fraction. So 3 miles per 1 hour. Okay, and then I'm going to write a little bit of multiplication sign, and I'm going to find another unit fraction. Unit means like 1 basically. So a fraction of units that are the exact same. But my goal here, they're asking me how many kilometers per hour does the person walk, which means I don't want miles. I want to get rid of miles. So I'm going to put miles on the bottom. Notice this is different than when we do proportions where we keep them in the same spot. I'm going to put miles on the bottom so that these end up canceling out. And then I'm hoping to be left with kilometers, but I don't have kilometers here. So what I'm going to do is I'm going to put kilometers on the top. So if I put miles on the diagonal, then those will cancel when I multiply, and then I'll be left with kilometers over hours. So now I have to figure out, well, what is the conversion between kilometers and miles? Well, we know up here, we wrote it down, we know that there are 5/3 kilometer per 1 mile. So 5/3 kilometer divided by 1 mile, this is essentially just like 1. So we're multiplying this original number of 3 really by 1. That's why we're allowed to do this, and this works. So when we multiply fractions, we cross out anything that's the same along the diagonals, and then we multiply across. So we're going to do 3 times 5/3. So 3 times 5/3 is going to be on the top, and then 1 times 1 is on the bottom. So that bottom we don't really even need to write. So I'm going to come over here, 3 times 5/3. Okay, I'm going to put the 3 over 1. The 3's end up canceling, and I'm left with 5. So I'm left with 5, and then if I'm not sure what unit is left, go back to the problem, okay, and identify, what units are still left over. Well, we have hours on the bottom and kilometers on the top, so this is going to be kilometers per hour, okay. So let's look at the next one. So I'm going to approach it the same way. So I'm going to look at what's given. So the car is traveling 90 kilometers per hour, and I'm going to write that as a fraction. Okay, I'm going to multiply it. What is the speed in miles per hour? So in this one, I don't want kilometers, but I want miles. So since I want to get rid of the kilometers, I'm going to put the kilometers on the diagonal from the original kilometers so that these are going to cancel out. And then I'm going to put miles on the top because I know a miles to kilometer conversion. So I know there's 1 mile for every 5/3 of a kilometer. So the units that are left over are miles per hour, which is what I want. That's what the question asked me to find. So now I'm going to multiply straight across. 90 times 1 is 90. And 1 times 5/3 is 5/3. I'm left with miles per hour. Now you might be looking at this thinking, well, what the heck does this mean? Well, I would write this horizontally. It would make sense to do it that way instead. So we're going to write 90 miles times, whoops, not times, divided by 5/3. And then remember, with fractions, if we're dividing fractions, we keep it, change it, flip it. So that means 90 times 3/5. So we change the division of multiplication. So 90 times 3, or you could cross multiply here. You could say 5 goes into 5 once, it goes into 90 18 times. 18 times 3 is 54 miles per hour. You can also use a calculator for this. You'll just type in 90 times parentheses 3 divided by 5, and that would be okay too.